Good morning. In these few slides, we will review mesh, nodal, and Thevenin circuits. Let us start with these two circuits. We will solve them using mesh and nodal. So let us start with mesh analysis. First of all, we will assume the current directions, I1 here. Then we'll put the polarities for each component. So positive and negative for the E1. And for the first resistor, it will enter from the bottom up, so we will have positive, negative. The other resistor R2, it will enter from the top, so we'll have positive, negative. Then for the second loop, we will have positive, negative, opposite direction, and positive, negative, negative, positive for the power supply. So we will apply then later on Kirchhoff voltage law in loop 1 and loop 2. So you'll have the first volt plus the second voltage drop, the third voltage drop. Adding these three voltage drops in this loop together, we will get equal to 0. Then for the second loop, we will add the first voltage drop, the second voltage drop, the third voltage. If you add these together, we're supposed to get to 0. So let us start with loop 1. Loop 1, we will start with P1. Then we will take the sign as we go out. It's minus VR1. We take the sign as we go out of the element. Minus VR2 equal to 0. And this is the final equation here for loop 1. For loop 2, we will start from taking the sign as we go out of the element. So we will start from VR2. It's minus VR2 minus VR3 plus E, because we take the sign as we go out. And the final equation will be, it looks like this. Then we can solve these equations together using substitution or the matrices or whatever. So this is using mesh analysis. Using nodal, what we need to do, first of all, we need to define the nodes. So for this circuit, we have only one node. Then we assume that all the currents are going out. And in this case, we have I1, I2, and I3. Then we will write Kirchhoff current law. And for this node, summation of In equals summation of I out. And we will start adding I1 plus I2 plus I3 equal 0. And so I1 is V1 minus the voltage E1, because it is positive here, it's positive E1, V1 minus E1 over R1. Then I2 is V1 over R2, and I3 is V1 minus, and we have the minus sign because the voltage source is flipped here. So V1 minus minus E1 over R3, and we get the value of V1 equal to 4 volts here. Okay, so this is, now the second part is Thevenin theorem. Let us solve this circuit here. Find the value of R that can absorb maximum power and calculate the value of the maximum power. So what we should do here, so the first step is to find R Thevenin. And to find R Thevenin, we need to remove the resistor R. Then we have two sources here, voltage source and current source. So we short circuit the voltage source and open circuit the current source. And we find the value of R Thevenin by looking from the open circuit part, and we can see here we have 4 and 4 in parallel, and R Thevenin equal to 2 ohm. The second thing, we need to find out E Thevenin. How can we find E Thevenin? By looking to the circuit here, E Thevenin is exactly equal to the volt on R2. So if you can find VR2, it will be the same as V Thevenin. And to find VR2, we need superposition here because we have two sources. So we will have two circuits. In the first circuit, we will enable the current source and short the voltage source, as you can see here. And in the second circuit, we will open circuit the current source and enable the voltage source. And by looking for the first circuit, it's the current, which is 5 amperes, will split between 4 and 4 ohms. So we'll have the current in R2 will equal to 2.5 ampere. And for the second circuit, the current in R2, which will equal to 24/8, which is 3 ampere. So the total current in R2 equal to 5.5 ampere, and the voltage will be 5.5 ampere times force will be 22 volts. So we will end up having E Thevenin equal to 22 volt, R Thevenin equal to 2 ohm, and the value of the resistor that can give maximum power should equal to the value of R Thevenin, and in this case it will be 2 ohm. So we can calculate the total current flowing in the circuit, which is 22/4, which is R Thevenin plus the load R, and it will be 5.5 ampere. And that's it. So in this short video, we managed to review mesh analysis, and we managed to also review Nodal and Thevenin theorem. And if you have any further questions, please contact me. Thank you very much.